kinetic theory. The other thing I know about kinetic theory is those three governing equations that we went over. So the kinetic energy is 1/2 mass times velocity. We went over the collision frequency, and we went over the momentum or impulse and put it together into the pressure. You don't need to know a derivation. Then there's a couple formulas that come out of it. We derive the ideal gas law. We derive the kinetic energy. Another thing that comes out of that through the derivation, again, you don't have to know the derivation, is this other formula that was asked about, the root mean square velocity. It's essentially the average velocity. It's not exactly the average. I'll just give you a couple tidbits about it. Temperatures in what units? Kelvin. M is kilograms per mole. It's not the molarity. It's the molar mass. R, which R do you use? The 8 or the 0.08? The 8. 8.3145 joules per mole Kelvin. 3 is just a number. If you put all those units in, what units will you get out? Meters per second. You know that because that's a velocity. So it has to be meters per second. Those are all SI units. This is a plug and chug. You know you're using this formula in particular if you're talking about one compound only. You know, what's the velocity? Okay. Now, if you have one compound and it asks for the velocity, but it gives you the wavelength, you're going to use what formula? If it gives you the wavelength, use what formula? De Broglie. But this is no wavelength related. Okay, you just have the compound. All right. Gas properties, I'll just say a couple things about that. All you need to know for the gas properties, that's all in the reader and in the textbook. There's a couple gas properties given in the beginning of chapter 6. Basically, that gases is you can expand or compress a gas. They have relatively low density. They diffuse. They don't have a definite shape or volume, things like that. Other things in gas properties, pressures, force over area, thank you. And then this other one, which is related to the barometer. So the barometer, the manometer, the conversions all come in that section. And that's with barometer or the manometer, use this version here. This, basically, whenever you're dealing with a liquid, you're going to use this type of formula. Okay? So pressure of a liquid, like under a swimming pool, under the ocean, or barometer, or manometer, use this version. What units do I recommend? SI units. So pressure is pascals. Density, what's in the numerator? What unit? Kilogram per meters cubed. This is a constant, 9.81 meters per second squared, that's given. And this is just the height. The hardest part about this problem is just converting two SI units. Okay, so you have to convert two SI units to make this work. You don't have to, but I recommend it. I think it's much easier. So almost every formula, except for gas laws, I recommend SI units. Okay, so that's it with that one, the barometer. You just plug it in here knowing the height of the liquid. Okay, should I just end with a little bit on Dalton before we go to specific questions? Dalton, does that sound like a good thing to cover? Okay. Dalton and Dalton over water. I'll try to hit both of those. Sorry, we didn't get to the ideal gas law or chapter 5. You can ask me during specific questions if you want, or office hours, or go see a TA. I'm sure they will help you. Okay, for Dalton's law. Dalton's law, you recognize it because there's more than one gas. And another obvious find is it talks about partial pressure. So you see the word partial in there. Or maybe mole fraction. Okay? So a typical setup of this, and again, if you're from a different instructor, they might set these questions up slightly differently than me. But you're going to be dealing with two gases. Let's say gas X and gas Y. And in some way they'll be separated, and then in the problem they'll be typically brought together, though they could start off together. Okay, so some sort of wording like that is what you're looking for. And then we'll typically want to find the moles of these. There's two ways that that happens. Either we give you the mass. If I give you the mass, then what happens? What do I do to get moles? Molar mass, periodic table, if mass is given. Or we give you information related to the ideal gas law. So you have pressure, volume, and temperature. Plug it into ideal gas law to get the moles of X and then the moles of Y. Once you have the moles of X and Y, then if you're asked, you can find the mole fraction. Say you want the mole fraction of little y. Then that would be the moles of y over the total moles, for example. The next thing we could ask you is the total pressure. So there's two scenarios for the total pressure. One is we give you the total pressure. So we literally tell you this is the barometric or atmospheric pressure. Or that's the easy way out. Don't always do that. Or we ask you for the pressure, or we don't even ask you, you just need to know, you need to find it. Okay? So I typically, in my class, we call that P total. And often you can get it from the ideal gas law. So if you know N total and V total, where do those come from? N total is from the total number of moles, which would be Nx plus Ny in this case. V total is usually given. So either we tell you the final volume, say is 5 liters, or we say that this container, this gas was 5 liters and this one was 10 liters. We put them together, made a total, so that's the total contained gas size is 15 liters. So it could depend. Either you're adding two volumes or we just give you the final volume. And you find P total, then you could use Dalton's law. Dalton's law would be Pi, Xi, P total. So you need the mole fractions times P total. And that's it. It's P total you would find or given, Xi or the mole fraction you just found. Okay, so it's a typical setup like that for me. I do want to say something about the Daltons over water. How do you know it's a Daltons over water? You either see the term something like collected over water or over water in the question. In that case, it's actually not a hard problem if you know the two equations to use. Okay, so the two equations for kind of a collected over something would be P total equals P gas plus P of, well, basically the liquid. Oh gosh. Oh my God. Liquid, there we go. Okay, so typically the liquid in most all cases would be water. So this would be the vapor pressure of water is what you're putting on there. Where do you find that value if it is in fact water? Yeah, if this is, in some cases that might be given in the question, so we tell you this partial pressure or this vapor pressure, or it's on the back of the exam. So it's listed in a table on the back of the exam, cross-listed by the temperature. Okay, P total, where the heck does that come from? It's a given, but what is it called? Not always P total. It's called usually the barometric or atmospheric pressure, typically. So this is typically called the barometric pressure or atmospheric pressure. So this is from a table or given in the question. This one is given in the question, but called barometric pressure. So you find the pressure of the gas, which is usually the product of a reaction. So this comes, remember, from a reaction. So some sort of reaction is happening in the question. Okay? Then, sometimes that's it. But if the question wants to ask you more, there's only one other equation you typically have to deal with, and that's the ideal gas law. Okay? Where this one is the pressure of the gas, and this is the moles of the gas. Okay, so typically what happens is these two formulas intersect on this variable right here. Once you know pressure of the gas from the top equation, you can stick it in the bottom one, and there's a couple things we can do with this. We could ask you for the moles of the gas, that's pretty common. Or we could ask you for the mass of the gas, which you would get how? Yeah, you can get from here, if you convert using the periodic table, you can get the mass of the gas. Or sometimes we give you this number and we ask for the volume. So those are a couple variations of it. Again, you'd have this pressure Then you find either the mass of the gas, or the moles of the gas, or the volume, and everything else, other variables would be given. Sometimes in one of the homework questions, if you did my homework, we started off, I think, with this number, and you had to work backwards. But it was the same question, these two formulas though. So wait, let me circle the formulas just so. Crystal clear here, that one, and sometimes that one. Maybe half the time the second one, yeah. Kind of. Yeah. Oh great, the mass of the gas, in this case, if you did no conversions, is in what units? Anybody? No conversions, the mass is in what unit? The mass. Grams. Grams. The reason is, N would come out in moles, and the periodic table's in grams per mole, in this case. Or if you're starting here, you want this in grams, because periodic table's in grams per mole, get you moles here. Pressure comes out in what units in this formula? Atmosphere. However, typically these units are usually what's called millimeters of mercury, mmHg. All right, it's about 9 o'clock now. Unfortunately, we didn't get to finish everything. You can ask me more later. I want to excuse people who want to go watch TV and stuff. Okay? Hope those of you who are leaving, hope you enjoyed it. I hope this was helpful for you. I do want you to do well on your exams.